Hey guys. So today is let's see, this is for Monday, April 4th, I believe. Man, that's a really bad glare in the back there. I'm sorry about that. Um, but this is for Monday. I believe the date is April 4th. We're on lesson 11.5. Okay, that can be found on page 421. All right, so if you don't have your books open yet, go ahead and do that. Excuse me while I move things around here. So we're going to be on lesson 11.5 today, adding and subtracting with a common denominator. We've covered simplifying, we've covered multiplying, we've covered dividing, and now today we're going to get into adding and subtracting. Today we're going to deal with common denominators. So if you're there in your book, 421, we're just going to start at the top here. These are very basic, basically the same rules as we have for adding and subtracting regular fractions, okay? So let's go ahead and look at our rules here, and let's just start off with that, okay? So our rules for adding rational expressions with a common denominator. We're going to start with adding. So number one, the first step is to add the numerators. Okay, and place over the common denominator. Okay, so our denominators in this lesson will all be common already, okay? So basically, we're just going to combine or add together our numerators, and we're going to place it over our common denominator to create one fraction, okay? That's the first step. Number two is to cancel. Okay, so we're going to cancel any common factors that are present. And then number three, we're going to set each canceled term or I shouldn't say term, I should say factor. Each canceled factor to equal 0, okay, just as we have been doing. And then number four, we're going to write the excluded values, just as we've been doing before. Okay, so real basic. This lesson really is not that difficult. We're covering basic common procedures here. Not real difficult. Let's take a look at how we implement these rules into an actual problem here. Okay, so for our first example, we've got 5x over 3 plus 4x over 3. Okay, we already have our common denominator of 3. Remember, when we're adding and subtracting, we must have a common denominator before we can add and subtract anything. These already have a common denominator, so all we're doing is we're placing them into one fraction. Okay, so we put both of them over the same denominator. Okay, then we're basically going to simplify or combine or add our numerators together. Okay, so we've got 5x plus 4x is 9x over 3. Now remember, when we're adding terms, okay, when we're adding terms with variables, we're adding like terms, meaning I can only add an x to an x squared to an x squared, an a to an a b squared to a b squared, and so on and so forth, okay? And by adding those terms together, the exponent does not change. It remains as it is on the terms that we're adding together, okay? So this is not 9x squared, okay? This is 9x, meaning this is all of my x terms added together, okay? So do not change the exponents when we're adding these together. Okay, so I've got 9x over 3, and then I'm just going to simplify, okay, or cancel my like terms. So 3 goes into 9 3 times. Okay, so I'm left with 3x over 1, which is 3x. Okay, now there were no variable terms that were canceled out. So there's no setting anything to 0, and there's no writing our excluded factors there. Okay, because there were none that were, no factors, variable factors that were canceled out, then just 3x is our answer. Okay, real basic. Let's try another one. Okay, so in this one, we've got 3x over x minus 3 plus 4x over x minus 3. So we're going to rewrite these together, 3x plus 4x over x plus 3. And then we're going to simplify it by combining these two together, okay? So I get 3, what am I doing? Hello? I don't know what is going on with this thing today, but it is not happy. So we've got 4 plus 3 is 7x over x plus 3, okay? So we write them. By the way, if you'd like to skip this step, you can. You can go right from this step to this step, and that'd be totally fine with me, okay? This step is not totally necessary. They're just breaking it down in small, simple steps for you. But if you want to skip this step of writing them separately and just combine them all together, you can do that as well. Again, no, nothing to cancel. So there's no setting to 0 and no writing our excluded values. So basically our answer is just 7x over x plus 3. All right, let's look at another one. Okay, so in this one, we've got 5x cubed plus 7x squared minus 3x plus 1 over 4x plus 3x cubed minus x squared plus 5x minus 1 over 4x. Okay, now we would combine all of these together. Okay, so we're looking at 5x cubed plus 7x squared minus 3x plus 1 plus 3x cubed minus x squared plus 5x minus 1, okay? And all of this is over our common denominator of 4x, okay? Now, we're going to combine our like terms. So looking at my cubes first, since that's my highest exponent, I've got a positive 3 and a positive 5. So I've got 8x cubed. All right, those are done. Then I look at my squares, 7x squared and a negative x. So I've got plus 6x squared. That's done. Okay, then I look at my x terms, negative 3x, positive 5. So I get plus 2x. And then I've got a negative 1 and a positive 1, and those totally cancel out and are gone. So I've got 4 over 4x. All right, now typically this would be our answer. However, because we can factor this down further, we're going to factor it. So I look at all of these terms and I say, okay, these all have common terms that I can factor out. So I'm going to take 2x and I'm going to factor it out of each of these terms. If I factor out 2x out of 8x cubed, I get 4x squared. If I take or factor out 2x out of 6x squared, I get 3x. Okay, and then if I factor out 2x out of 2x, I get 1. Okay, over 4x. Now, looking at this, now I have terms that can cancel out. Okay, so 2 goes into 4 2 times, x into x, so I get 2 as my new denominator. Okay, so my answer then is 4x squared plus 3x plus 1 over 2. Okay, now I have to go back and look at my excluded variables. Okay, so the only variable that was excluded here is x in this case. So x equals 0. So my answer is 4x squared plus 3x plus 2, where x does not equal 0. Okay, so again, once I combine, add everything, I can factor, so I factor. And then after factoring, I see I can cancel, so I cancel. And in canceling, I canceled out my x. And because I canceled out my x, I have to exclude that from my domain. Okay, so the process is very simple. Okay, we're just adding our like terms, factoring if possible, canceling, and then excluding values that are canceled, or excluding variables that are canceled out. Okay, let's look at another one. I've got 3x plus 11 over 8x squared minus 2x minus 1 plus 2x minus 4 over 8x squared minus 2x minus 1, and there's such a delay on this right now, plus negative x minus 6 over 8x squared minus 2x minus 1. Okay, so I'm going to write these all over, oops, excuse me. I'm going to write all of these over my common denominator, okay? Now, because I have a negative, this is how I'm going to write this, all right? I'm going to go 3x plus 11 plus 2x minus 4 plus a negative x minus 6. Okay, over my common denominator of 8x squared minus 2x minus 1. Okay, so because I have that negative there, I'm going to go ahead and just write these in parentheses. It's a little easier, so you can see what we do in our next step here. So I've got 3x plus 11 plus 2x minus 4. And because I've got a plus here and a negative here, this is actually minus, not sure why I put that there. Sorry about that. Minus x minus 6. Okay, so see how we did that? Because we're adding them together, but because this is a negative, it actually becomes minus x minus 6. Okay, over 8x squared minus 2x minus 1. Okay, so now we're going to combine our like terms. Okay, our highest variable here is x squared. Okay, so I've got 3x, or excuse me, not x squared, x. I've got 3x plus 2x is 5 minus 1x is 4x. Okay, so that takes care of this, this, and this. Now I've got 11 minus 4 minus 6, okay, which gives me a positive 1 over 8x squared minus 2x minus 1. Okay, now that I've combined everything together, now I can factor if I can. Okay, so my denominator can obviously factor. Okay, so I've got 4x plus 1 over, and we're going to factor 8x squared minus 2x minus 1, okay? And this comes out to 4x plus 1, 2x minus 1, okay? Now, once I've factored everything, then I do my cancellation. This cancels out and this cancels out. That leaves me with 1 over 2x minus 1, okay? Now I go back and include my excluded values. So my 4x plus 1 was excluded. So I have to solve for 4x plus 1 equals 0. Okay, which gives me, okay, x equals negative 1/4. So my answer is 1 over 2x minus 1, where x does not equal negative 1/4. And that's my answer. Okay, so the process is simple. All right, we combine them all together. Okay, we combine our like terms. Okay, then once we've combined our like terms, we factor. And once we factor, we cancel. And then whatever's left over is our answer, including our excluded values that we have to determine at the end according to what was canceled on those. Give me just a moment here. Okay, sorry about that, guys. I had to get lunch for my kiddos. Okay, so when we're talking about adding these rational expressions, the process is very simple. We combine all together over one common denominator, okay? We then combine terms, okay, in our numerator, okay? Combine all of our like terms. And then once they're all combined, then we factor whatever we can factor. And after factoring, then we cancel, and whatever's left over is our answer, okay? Now, we also have to include our excluded values. So whatever was canceled out after factoring, whatever was canceled out, then needs to be included in our answer, our exclusions there in our answer. Okay, so hopefully that is understandable. Okay, so that is the basic steps for our rational expressions of adding these rational expressions of I'm sorry. Okay, let's look at page 422. I've had more distractions while I'm recording this lesson than any ever, unfortunately. So bear with me here as I try and refocus. Bottom of page 22, under example 11.5d, it says when subtracting, the sign of the subtrahend is changed and the problem is made into an addition problem. The same principle applies to subtraction of rational expressions. So now we're going to look at our subtraction of rational expressions. Okay, this is not much different than adding, because as we just read, basically all we're doing is changing the signs of the subtrahend and adding. Okay, so let's take a look at these here. Okay, these are our steps for subtracting rational expressions. Number 1, change the subtraction to addition. Okay, so all of our subtraction then is all of our subtraction signs between our fractions are changed to addition. Okay, and then number 3, we are going to add the numerators. Add the numerators and place over the common denominator. Okay, so you'll notice this here is the same step as from addition. So once we change the signs to addition, once we change our subtraction signs to addition, we're basically just following our same steps as addition. We add, we cancel, we set, and then we write. Okay, so same steps as addition after we change the subtraction sign. So let's look at this process then of changing the subtraction signs. Okay, what do we do to change our subtraction signs? Well, let's take a look at this. If I have 4 over x, okay, minus 3 over x, and I'm going to change my addition to, or excuse me, my subtraction to addition, that means every sign in my problem is also going to change. Or excuse me, not every sign, but let me break this down for you. Okay, my 4x stays the same. Okay, now when I'm going to put an addition sign there, I'm basically going to take this subtraction sign and I'm going to apply it to my numerator. Okay, one of my terms. All right, so this is going to be written as negative 3 over x. In other words, this here, negative 3 over x, is the same exact thing as negative 3 over x. Remember, when we have that negative sign, okay, this applies to one, usually the numerator, applies to one of these numbers, okay? So we're basically just rewriting this so that our top number has, our numerator has the negative, and then I'm just adding this fraction together, okay? So let's work through this then, okay? So now I've got 4 over x plus negative 3 over x, okay? So now I'm just adding or combining over one common denominator, so 4 plus negative 3 over x, okay? Now the reason why we did not apply this negative x, or this negative sign to the denominator, is because then my denominators would be different, okay? So we're applying this negative sign to our numerator so that my denominator stays the same, okay? Just pointing that out there. All right, once I've combined them over the same denominator, then I can add them together. So 4 plus a negative 3 is 1 over x, okay? And nothing's been excluded, so I don't have to go through those last steps. So this would be my answer. All right, let's try another one so we can get this down in our head of how to change our subtraction sign to an addition sign. So if I have 3x over x plus 1 minus 4 over x plus 1, okay? So I'm going to apply this negative sign to my 4, and I'm going to add a plus sign between my fractions. So I've got 3x, x plus 1, plus negative 4 over x plus 1. My denominators are still the same. I've just applied this negative sign to my 4, and I add them together. Okay, so once I change my sign from my subtraction to my addition, then I'm combining over the same denominator. Okay, and then I combine my my like terms together. Okay, so 3x and 4 are not like terms, so I cannot combine them together. So I'm going to write this as 3x minus 4 over x minus 4. Okay, now there's nothing to cancel out here, okay? So I'm not canceling anything out. There's nothing to factor. So my answer is 3x minus 4 over x minus 4. Now I know that this looks like this could cancel, but remember we're looking at this as a whole, okay? 3x minus 4 is not the same as x minus 4. We cannot cancel these two or reduce them out, okay? So the answer just remains 3x minus 4 over x minus 4. Okay, let's try another one. Hopefully we're getting this idea down of changing our subtraction sign to our addition sign. Okay, so I've got 2x plus 1 over x squared minus 4x plus 3 minus x plus 2 over x squared minus 4x plus 3. Okay, so I'm going to apply my subtraction sign to my numerator, and I'm going to change this to an addition. So I've got 2x plus 1 over x squared minus 4x plus 3 plus a negative x plus 2 over x squared minus 4x plus 3. Okay, so I applied my subtraction sign to my numerator, and I put an addition sign between my fractions. So from here, all I'm doing is combining together over one common denominator. So 2x plus 1 minus, let me just do this the right way here, plus, let's do this like this. Do I want to do it that way? Yeah. Okay, let me back up here a second and explain what I'm doing before I do it here. Okay, if I'm going to combine these together, okay, remember when we have a negative sign outside of a parenthesis, okay, everything inside the parenthesis changes. So my positive x becomes a negative x, and my positive 2 becomes a negative 2. So when I combine these together over one common denominator, I have my 2x plus 1, And now this x is a negative x because of the negative sign outside. And this positive 2 is a negative 2. Okay, so when we're combining these together, I have this negative sign here that changes my signs inside. Okay, in other words, I can rewrite this like this. I can say 2x plus 1 over x squared minus 4x plus 3 plus negative x, minus 2 over x squared minus 4x plus 3. Okay, so we're still following our basic algebraic rules. When I've got a negative outside of a parenthesis, okay, then the whole, every sign inside gets changed, okay? And the reason why we put this in a parenthesis is because x plus 2 is together, okay? I can't just put negative x plus 2. The whole thing is negative. The whole numerator is negative, so that negative applies to everything inside of my parenthesis, okay? So we change the sign from subtraction to addition and apply that negative sign to my whole numerator. By doing that, I put my numerator in a parenthesis, and that negative goes on the outside. Anytime I have a negative on the outside of the parenthesis, every sign inside changes. Okay, so my positive x is a negative, my positive 2 is a negative. Now I can combine these together, saying 2x plus 1 minus x minus 2 over x squared minus 4x plus 3. Okay, so we have to first change the signs before we can remove our parenthesis. Okay, as we're removing our parenthesis, we have to remember these are going to flip sides. Okay, what was positive will be negative and vice versa. Okay, so here's where I'm at here. Now I can combine my like terms together. So I've got 2x and a negative x, so that leaves me with x. And then I've got a positive 1 and a negative 2, which leaves me with a negative 1. And I'm going to factor my denominator, okay? So x squared minus 4x plus 3 factors to x minus 1 times x minus 3. Okay, hopefully you're still with me here. So we combined, then we factored, and this is where we're at here. So now I do my canceling. This cancels with this, leaving me with 1 over x minus 3. Now, because my x minus 1 was excluded, I have to put this to equal 0. So my answer is 1 over x minus 3, where x does not equal 1. Okay? So I know that seemed a little confusing. Just follow your basic addition steps. The only thing that's different in this is changing our subtraction sign to our addition sign. Okay, once you do that, everything past that is just regular addition rules. Okay, so give these a shot. If you have any problems, let me know, and we can re-explain these. And I do want you to get a hold of me if there are issues. Okay, let's not wait until it's too late to deal with these issues. Okay, so for your homework for tonight, I want you to do 1, 7, 13, 19, and 23. Okay? 1, 7, 13, 19, and 23. That's right down the left column there of practice 11.5 on page 424. If you come across any questions or you don't understand something and you'd like something re-explained, get a hold of me and we will go over that. Now, as I said last lesson, we are up against a quiz here. This quiz is over sections 11.1 to 11.4. So let me just give you a rundown here of what's going to be on this test, or excuse me, quiz. Okay, this is quiz number 34. All right, so take some quiz notes here. This is over sections 11.1 to 11.4. We're going to take this Tuesday, tomorrow. Okay? Unless you get a hold of me and need something re-explained, and I feel we should postpone it, then we will. But for right now, we're scheduling it for Tuesday. And this would be Tuesday the 5th, May 5th, okay, is when we would take that. All right, so your first three questions, 1 through 3, all we're doing is evaluating each rational expression with the given values. So they'll give you something like this. Okay, and then they'll say x is equal to 2 and y is equal to 3. Okay, and then you're going to plug these values for x and y into here and solve. Okay, so that is 1 through 3 of those. Okay, now remember, I want you to remember this and put this in your notes. Anything over 0 is undefined. Okay, so if we plug in these values for x and y and we multiply and reduce and all that, and I get a number over 0, my answer is not that number over 0. My answer is undefined. Okay, so all we're doing on 1 through 3 is taking the values that they give us for x and y and plugging them into the fraction or rational expression that they give and solving. Okay, or when I say solve, I mean combining and multiplying and that sort of thing, okay, till you break it down and get a fraction or it comes out undefined. All right, numbers 4, clear this. Okay, numbers 4 and 5. Numbers 4 and 5. Okay, indicate the values at which each expression is undefined. Okay, so indicating undefined values. Okay, so how do we do this? Remember, we take our denominator. So let's say I've got x squared plus 2x plus 4, okay, over x plus 3, okay? And I have something like this, and I want to find out which values are going to be undefined. They're not going to be included in my domain. So what I do is I take my denominator, okay, x, I don't know what I did there, x plus 3, and set it to equal 0, and then solve for x, okay? So my answer then would be x equals 3. That would be the indicated value that would be undefined in this circumstance, okay? So we take our denominator, we set it to 0, and then we solve for x. There are 2 of those. 4 and 5 of the quiz are, okay. 4 and 5 of the quiz is that, okay? 6 and 7. 6 and 7 is just writing the reciprocal, okay? Remember, the reciprocal is the inversion of the fraction, okay? So we take our fractions and we flip them upside down, okay? If I have, let's say I have this, x and y, what would be my reciprocal for x and y? Remember, if it's not a fraction already, we understand it to be over 1. So if I have just x and y sitting there, then I know that that's technically x and y over 1, which means my reciprocal then would be 1 over x, y. Okay, so we have to flip that over, and that would be the reciprocal. So anytime I have a variable a, b, okay, and it's just sitting there, what's the reciprocal of this? Well, it would be 1 over a, b, because technically we know that a, b is over 1. All right. Okay, next. 8, 9, and 10. Okay, 8, 9, and 10. So 8, 9, and 10 are multiplying and dividing the rational expressions. Okay, multiplying and dividing rational expressions. This you will be including, okay, your excluded values. All right. So if I have two multiplication problems, okay, we know that we have to factor first, and then we cancel. And then after canceling, whatever's left over is your answer. And then you take the excluded values and you put them to equal 0 and solve the problem, or solve for x, okay? And then by solving x, that is what your excluded value is, okay? So you're both doing the multiplying and then you are finding your excluded values. Both of those are on there. So you'll have two that are multiplication and one that's division. Remember, division is really no different than multiplication. You just have to invert first, okay? And remember, if you have a term that was originally in your denominator before you inverted, okay, then it has to also be included in your excluded values if that number or factor is not in your final answer, okay? And we've talked extensively on that. Okay, so just to review, 1 through 3, okay, we're just evaluating the rational expressions, plugging in your values for x and y that they give you, and solving, okay. Numbers 4 and 5 indicate the undefined, okay, so find your undefined answers by taking your denominator, setting it to 0, and solving. And 6 and 7 is just writing the reciprocal. Reciprocals is just taking that fraction and inverting it. That is the reciprocal. And then 8 and 9 are multiplication of rational expressions, and 10 is the division of rational expressions. Okay, so that'll be your quiz. We'll take that on Tuesday. And in the meantime, we will continue to move forward. You know what, we'll take that. No, I'm sorry, we'll take it on Wednesday. I don't know what I was thinking, because this lesson is for Tuesday. So we'll take that on, no, this lesson is for Monday. Man, I'm getting all confused here. Let's just go ahead and set the quiz for Wednesday, okay? That way I'm sure that you guys, I'll have time to look over your homework, make sure you grasp that information. So we'll take the quiz on Wednesday, and your homework again for today is practice 11.5. 1, 7, 13, 19, and 23. Okay, that'll be due by the end of the day. All right. So this lesson is for Monday, April 4th. If you have any questions, get a hold of me and we'll get it worked out. But other than that, that's all I have for you guys. All right, guys, have a good day. We'll talk to you later.